Hello, Kevin. This is Hudson. Before I present the bill of quantity or the contracting bill estimate, I've just decided to show you the calculations of the square meters, particularly the backyard retaining walls. Right. So, for example, if I'm gonna base the total square meters after calculating all these dimensions, so the size is sort of adding up to a lot of square meters, because the most important thing is we need to order right quantity of materials, for we don't want to be short and we don't want to have to extras. So I have a sort of a spreadsheet that I'm using to sort of get an idea of actually what we are looking at. So I'm just gonna quickly sort of show you. So what I've labeled here, I have wall A, I have wall B, and the length and the height, just to get the square meters. All right. So let me just sort of take it back again. For example, if I want to sort of find out how many square meters this wall, okay, and this one has altogether, so I could sort of label this as wall A, and this is wall B. Alright, so I'm gonna go back to my spreadsheet. Alright, so for wall A, it's got a length of it's got about 13 meters, but it's adding up to too much, right? So let me say, but I'm gonna split it. I'm only gonna sort of calculate this front face, because it's curving. It's got this. It's gonna curve this side, and it's gonna curve that other side. Same applies with this one. It's got a front face, and it curves on the other side. So right. So these are my calculations for OA. Instead of 30 meters, I'm just gonna say, okay, let's say 11 meters, and with a height of 7,6. So we are getting 83 square meters, right? So it's 11 multiplied by 7,6. We've got 83 square meters. And for wall B, the other wall, this is wall B. All right. So let's say 12 by a height of 6.5. But I've just adjusted a little bit. Okay. So that's 10 multiplied by 6,5. We're getting 65 square meters. So to get just the front dimension, so for the two walls, we have a total of this plus this. So it's about 148 square meters. Right. I also want you to confirm these dimensions, so we can be on the same platform. Right. So now if I go to the sides now, so instead of breaking, just like a summary, because I would want to sort of say this side is separate. I mean, I'm talking about this curve here, and the other curve on the other side, and these curves, and these curves. So what I've done is, because from where the curve starts to where we're gonna end, from last time my measurement was about 8 meters. Okay, let me say 7 meters. So it's forming like a triangular shape. So I'm gonna say 7 plus this side is 7. Then I've got 18, and then I'm just gonna use a single height. So this is 7.5. So I'm saying half of 7.6 meters, and then I'm gonna multiply with the total length of these dimensions, right? So initially I'd said it's gonna be like 8 plus 8, but let me just say 7 plus 7, just to avoid overestimating, right? So for wall A, both sides, both curves, with a height of half of 7.6. So we're looking at about 44 square meters. And then the other one, it's gonna be the same. It's 14 with the height. Since the height is gonna be 6.5, so I'm gonna say half of 6.5. So half of 6.5 is probably about 3.2 as well. Yeah, 3.2. Right. Same applies. But I think this one here is 7.5. So half of 7.5, probably 3.5. I'm saying 7.5, but it's on average it's about 7.6 meters. So let me just 7.5, 3.5. Right. So let me just split this total. So on the dimensions, we're gonna have a total of about 100 space on average. Right, about 93 square meters. Right. So now, just the total now. I don't know if I'm lost somehow. Please go through it, because that's how I'm actually getting the square meters. So I think what is actually sort of making these dimensions high is the height of the walls. So I'm gonna say now 148, the straight dimensions plus the caves. Alright, so I'm getting 242 square meters all in all. So now, if I'm gonna have to work out, the estimate or the construction bill, if I'm gonna have to base on 242 square meters, you know, it looks like it's prohibitively expensive. Okay. All right, and then another aspect of the project is the excavations. So we are gonna have to clear. Let me just put a single formula. All right, we have a bank that is gonna be about 34 meters multiplied by from where the existing retaining wall to close to the boundary. There is about 6 meters, about 6.5 meters, right? And the height, we're looking at about 1.5 meters just to get to the desired level, just like on this drawing here. Right, so I've got this length 34 meters, and I was talking about this dimension here from existing retaining wall to the boundary, and then I'm gonna also consider the height of the bank that we're gonna expose after the excavations. So now I'm going back to the formula. So so the height is going to be like 1.5, but we are going up at a certain angle. It's going down at a certain gradient, so it won't be like 1.5. So I'm probably going to have to say half of that. So half of 1.5 is probably going to be, let me just say 800, right? So with that, I can then actually find out how many cubic meters or how many tons of earth that we're going to have to clear with the TLBs and bobcats, right? So we're looking at about 176 tons that you're gonna have to dig and then push it behind all the house. So you know that is also another aspect of the project. All right. So now, if you confirm these dimensions and all these calculations, then I can go ahead and actually sort of work out the estimate. All right. So we have a total of about 242 square meters and about 180 to 200 tons of earth that we're gonna need to dig and push in our backyard. All right. So yeah, if you say we are now on the same platform, I can then go ahead and present the bill of quantity to you. All right. Thank you so much for watching.